Hello everyone, my name is Kim. Welcome to my video. I'm going to talking about over-the-counter drug, and today's topic is Monistat, or the generic name is miconazole. So Monistat is an antifungal medication used to treat fungal infections, particularly vaginal yeast infections. Its active ingredient is miconazole, which has the molecular formula CH10H14 Cl4 N2O. It was invented in 1969 and approved by the FDA in 1974. I have created a model which is made from foam and have label on it to identify each atom. As everyone can see in the picture, the models show the arrangement of the atoms and how they are bounded together. Each white cube represents a carbon atom, black represents hydrogen, green represents chlorine, blue represents oxygen, and red represents nitrogen. The sticks connecting the cube represent covalent bonds between the atoms. The model shows a complex organic molecule with two ring structures. The presence of carbon, hydrogen, chlorine, nitrogen, and oxygen suggests that this is an organic compound. These models have visualized the structure of the molecule to understand its property and reactivity. Now I'm going to explain everyone with Lewis' structure of miconazole. The structure shows how the carbon are connected to form rings and chains, and how hydrogens, chlorines, nitrogens, and oxygen are bounded to this carbon. As you can see, carbon has 4 valence electrons, hydrogen has 1 valence electron, chlorine has 7 valence electrons, nitrogen has 5 valence electrons, and oxygen has 6 valence electrons. It shows the single and double bonds between atoms, and as well as a lone pair of electrons. These structures have visualized the molecules bounding and the overall shape. Identifying bound ties. According to the image of the Lewis dot structure on the right side, we see that nonpolar covalent bond of CH bounds, polar covalent bond CCl, and CnCO bounds. There is no ionic bonds are present in miconazole. The molecular geometry of atoms except hydrogen in miconazole. Carbon atoms in the benzene rings have 3 bounding regions and no lone pairs, resulting in a trigonal planar geometry with bound angles of 120 degrees. And also we see a nitrogen atom in the imidazole rings also have 3 bounding regions, 2 single bonds and 1 double bond, and no lone pairs. This leads to a trigonal planar geometry with a bound angles approximately 120 degrees the same. Also the oxygen atom has 2 bounding regions and 2 lone pairs, with a bound angle of approximately 109.5 degrees, so it must be a bent. Last, the stronger intermolecular force. The stronger intermolecular force between two miconazole molecule and hydrogen bonding. Miconazole contain nitrogen and oxygen atoms. These atoms are electronegative and can act as hydrogen bound acceptor. When a miconazole molecule interacts with another miconazole molecule, the partially positive hydrogen atoms of one molecule can form hydrogen bound with the partially negative oxygen, or the nitrogen atom of the other molecule. So these are my reference, and thank you for watching my video.